Creating the Army aviation fleet of the future is no small task.
Although we have incredibly survivable aircraft now, the threat continually changes, the enemy continually changes the technology and the tactics that he uses against our fleet, and we need to get ahead of that game so that we're survivable. We're really focused on three main areas that we've evaluated as what we really need for the future: performance, survivability, and economy. Our legacy platform were designed for a certain fighting environment, and we found ourselves in an environment that's much more demanding, greater distances, the need for more speed, and the need to carry more payload.
Engineers had speed in mind when they developed the Army's Apache Block 3 helicopter.
One of the major enhancements of the aircraft from a performance perspective, it's the fastest, strongest Apache we've had to date. I like to label it as riding a stallion, an Appalachian stud horse, because if you've ever ridden one of those, you know that it likes to go fast and it likes to go hard. That's really what this aircraft does. So at a payload that's much greater than what the Apache has ever carried before, it's going to be able to fly to spaces and places in Afghanistan, as an example, that our current Apaches cannot fly. So that's a significant enhancement to the aircraft because it's going to protect lives. So those ground troops that are up on the mountainside in Afghanistan right now that don't have air coverage because the Apaches can't get there, the Block 3 will change that.
The Apache Block 3 also has an upgraded electronics backbone.
One of the things that backbone allows us to do is networking and future capabilities that really are breaking the new technology barriers.
Capabilities that the Army says will enable the highest levels of interoperability between the pilot and the Army's fleet of unmanned aircraft, also known as manned-unmanned teaming. The interaction between unmanned aircraft, ground control, and pilots is fast becoming one of the Army's most effective tools.
Manned-unmanned teaming, we've defined 4 levels from you just receive the video off the unmanned system into the manned aircraft, to both platforms being able to transfer the sensor data from the manned and the unmanned back and forth and down to the ground. The next level up is the operators of the manned aircraft controlling the payload or the sensor on the unmanned vehicle so they can make it look where they want it to look, which simplifies operation. And the most advanced way to implement manned-unmanned teaming is that the manned aircraft actually controls the unmanned vehicle, not just the sensor, but the whole vehicle.
Basically, the control on the Block 3 aircraft is the first manned platform to be able to do level 2 through level 4 control, which means you can not only receive the video from the UAS, but you can control the UAS's sensor, you can control the navigation of where the UAS goes. And so really, if you think about it from an operational sense, the Block 3 crew will no longer have to hear someone talk them onto a target, because a picture's worth 1,000 words.
Pilots flying the Apache Block 3 are actually able to fly an unmanned aircraft like the Army's Gray Eagle and the Shadow right from the cockpit of the Apache.
What's unique about the Army UAVs is you don't really fly them. You tell it where you want it to go, and it flies itself. It's on an automatic control, if you will, an autopilot. So different sort of from the Air Force UAVs where they actually fly them. We just tell them where we want them to go. And the UAV and the Block 3 aircraft actually share a database of control measures or waypoints. So I can simply, with a couple of button pushes, tell the UAV that I want it to go to a certain waypoint. And the UAV flies there. I can change its altitude, I can change its airspeed, and really via a couple of button pushes on the aircraft, I can send it wherever I want it to go. You don't actually fly it, you just tell it where to go.
That capability can provide invaluable information for pilots in the air and soldiers on the ground.
So the man-unmanned teaming works in several ways. The way I like to describe it is the hunting dog out in front of the hunter. When you know what's on the ground before you get there, when you know what your targets look like, when you know what the terrain looks like before you get there, it's a big advantage for that manned aviator. In addition, now with the incorporation of the laser designation, our UAVs can laze for a target, and then they can shoot their Hellfire missiles from a great distance, sometime without ever seeing the targets. Once those targets are engaged, then they can do battle damage assessment, all without ever flying over it and putting themselves in harm's way. So that's a very big advantage, in my opinion.
The manned-unmanned operating system is intended to work seamlessly between manned aircraft, UAVs, and a UAV ground station.
So why is interoperability important? It goes back to now that we've grown and are at all echelons of the Army, from small all the way to the big Gray Eagle, which is the Army's biggest UAV, to be able to talk the same language, to be able to share the same videos, to send the same messages up to the airplane and back, and to those same messages and photos, as well as full motion video to the tactical edge or to our UAV recipients. It's very important that we all have universal or interoperable products and standards.
The Army recently had the chance to demonstrate this cutting-edge technology at MUSIC, the Army's Manned-Unmanned Systems Integration Capability Exercise at Dugway Proving Grounds in Utah.
All of the MUSIC exercises are focused on getting new capabilities integrated into the platforms and out to the soldier.
In the old days, so to speak, we would look at a map and we would do as much map reconnaissance as we possibly could, and we would try to understand, looking at pictures, what it is that we're getting into. But now, literally with an unmanned aircraft vehicle overhead, looking at that landing zone in real time, that helicopter pilot is going to be able to know exactly what's going on, know exactly where he's going to land, and there should be less room for surprise.
I want you to keep eyes on him. Let me know if you lose sight if he's heading towards my direction. I'll go ahead and fall back. Right now, I'm trying to get eyes on him.
So obviously the benefit for the soldier on the ground is now he's got a level of situational awareness that he didn't have before, that just, really enables him to truly understand the situation that he's about to get into. And that's really a game changer for the Army. I mean, it's a huge capability that we didn't have in the past.
Another challenge facing military pilots today is the problem of degraded visual environment, or brownout, and a loss of situational awareness.
If you look at the mishaps that have happened over the last several years, there's a large percentage associated with controlled flight into terrain, degraded visual environments, meaning snow, dust, obscuration, and these certainly amount to probably at least 30% of the mishaps that we currently have now. Currently, when pilots are trying to land in a brownout now, they try to get the aircraft on the ground before the dust cloud catches up with them, so to speak. When they're coming forward and landing, the dust will be coming and approaching them from the rear. And a crew member will usually be calling where that dust is, and the pilot is hoping to get that on the aircraft, get the aircraft on the ground before the dust cloud envelops them. If they are actually in the dust storm itself, there's not a lot of ways to get information as to drift cues. And they may be moving and they're not aware of their movement. And if they're moving slightly laterally when they touch down, they can get what's called a dynamic rollover, and the aircraft will roll over.
The Army is working to change that with a variety of new technology.
We've broken the solution set for degraded visual environment into three major areas: handling qualities, cueing, and sensors.
Special sensors and radar that allow pilots to see through dust, snow, or any type of bad weather, and helicopters that can safely land themselves are quickly becoming a reality.
There are several technologies. A particular one that we picked to do a quick reaction capability is a 94 gigahertz radar called the Helicopter Autonomous Landing System, or HALS. And we're in the process right now of integrating that onto a platform.
The Army is also developing better ways to alert the pilot to potential danger. Angus Rupert believes that the answer lies within our sense of touch.
This is the basic way that we get information when we first start out as infants. It's through the sense of touch before our vision and auditory and other senses really develop very well. Touch is our most basic sense. Touch is the sense that is the most real sense. When you really believe in something, you can say, I can feel it, because it's that important.
The concept of tactile or haptic technology isn't new to most of us. There's the vibrate mode on your phone and video games like Wii and Xbox.
Touch information is information that we have used somewhat reflexively most of our life, such as, for example, when someone comes up and touches you on the shoulder and you reflexively look over, but they're standing on the other side because they've tapped you on the other shoulder just to play a joke on you. It's so reliant and so quick that you don't have to think about it.
So what does our sense of touch have to do with flying?
Pilots now, all the information that they get as to how they're oriented in space and what's going on in them around the environment is entirely by vision. All the displays are visual. They have attitude indicators that tell them in roll and pitch, whether they're pitched up or down, rolled left or rolled right. They have heading indicators to tell them what direction they're going. They have altimeters for altitude, vertical velocity indicators to tell them how fast they're moving up and down. The reason that we need tactile cueing for pilots is that pilots will frequently get distracted. And if they're attending to some other task, anytime they're not looking at their attitude-orienting instruments, they will be receiving information from their skin, muscle, and joint senses and their inner ear, and we call those the seat-of-the-pants sensations, and those sensations do not tend to be correct all the time while pilots are flying. And the reason for that is that as an aircraft makes maneuvers and accelerates, that information that is presented to the person flying is frequently false.
That loss of situational awareness can prove deadly for pilots.
Oh, God.
Our goal is that we prevent controlled flight into terrain by giving them a warning through tactile cues before they get to the point of impacting the ground, and that we give them continuous orientation information so they can never get disoriented to begin with. And hopefully that we'll be able to reduce the number of mishaps that pilots and our Army, Navy, and Air Force are currently experiencing.
Some of the tactor cues, you'll immediately start to feel the forward tactor fire. I have the forward tactor. And
the Army's tactile situational awareness system consists of a belt and vest that vibrate, sending signals to guide pilots in the air.
This is the dual tactor array of the TSAS belt. This is a prototype of a system that we're going to employ later in an aircraft integration role. And what I'm doing is putting it on at the lowest level, so it's just over my flight suit as I start to build up wearing my flight gear for the flight. Now, in future versions of TSAS, it could be integrated into the life support equipment, but that is an endeavor that we're still investigating. And so in this prototype application, we have a couple of tactors that we indicate high altitude alerts. Thanks, bud. And we just put them under here to make contact with the skin. That's the only requirement. And they're actually a separate portion. This prototype version is a separate tactor. And what we envision later for aircraft integration will be, this will be sewn in to the webbing of the shoulder harness, or could be part of the aviation life support equipment. So from here, it's just a matter of starting the aircraft up and conducting our checks, and we'll go fly.
There's many types of information that we can give to a pilot through the sense of touch. A simple little belt around the waist can give them drift cues in what we call the XY or the horizontal plane. So whatever direction they are drifting, they will feel a tap. So if they're drifting to the right, they will feel it on the right side. The faster they're moving to the right, the higher the frequency. So if they feel a high frequency, they will make a big correction. And when they feel the frequency going down, they can ease up on that correction. And when they feel nothing, they're in a perfect hover. If they go too far, then it will be tapping on the other side. So it's very intuitive. Now, pilots also want to control the altitude, whether they're too high or too low. If they're too high, they feel the tap on the shoulder built into the harness, and if they're too low, they feel these 8 tactors that are built into the seat. That too low stimulus will help a great deal with controlled flight into terrain, since when a pilot is approaching the ground and they're getting too low, they will feel this large stimulus in the seat that will say, whoops, you better be pulling up now.
U.S. Army aeromedical research pilots like John Remicchio are testing the latest prototype of the TSAS belt and vest in both simulators and in the air.
This technology is not only helpful in stabilization in brownout or whiteout, but it will augment our basic hover skill tasks. So if you can imagine a medevac pilot having to do a hoist off the top of a building, if you can recall some of the video footage from the Hurricane Katrina rescues, that stabilization during a hover is extremely workload intensive. And so with a system like this, you reduce the amount of workload, the amount of hand movements and scan that has to be done. So it'll augment just basic tasks, hoists, sling loads, external loads, things that helicopters do by the very nature of their creation. So it's a great tool. Frankly, in 21 years that I've been flying Black Hawks, this technology represents the most novel, intuitive, and easily integratable technologies that I've ever seen. That I really, frankly, don't know how we've been flying it so many years, you know, flying different systems, both fixed wing and helicopter, without this type of display.
Army researchers say that the potential applications for haptic and tactile technology go beyond hovering helicopters in degraded visual environments.
Another one is targeting, and for either helicopters or fixed wing. Where is their target around them in space? So if they feel something tapping them on their left shoulder, they'll know that the target is up there. They may not see it, they may not be aware of quite how far away it is, but they'll know it's on their left side, up over their left shoulder, and they'll be able to track that target. If, for example, it now moves down across their back and is on their lower right side, they'll know the target is down there below them on the right side. Now, normally, they get that information from an instrument that's on the panel, an APR-39, and there's an auditory warning first that all three people in the cockpit hear, and it's a very noisy environment, while 2 or 3 people are all talking at the same time. However, when we use the tactile display, there's only one call made, and the pilot will say, "I have it." This technology has applications whether we're on the air, on the ground, or underwater. On the most obvious application in terms of navigation on the ground is simple left and right, where targets are, where other people are surrounding you. And it can be used for the soldier, it can be used for people that have visual incapacitations, and it can provide an intuitive sense of how and where I am on the ground.
In fact, this technology is currently being tested as a tool for ground troops by the Army Research Lab at Fort Rucker, Alabama, and in Fort Benning, Georgia. This one works by punching in waypoints off of a tablet computer, but eventually this technology could work through a smartphone or a small screen on the sleeve.
So we did put the soldiers out in rough terrain during the day, at night, having them answer radio communications, look for targets. We compared it with other systems, handheld GPS, head-up display, and what we found was that they were just as fast or faster with the tactile belt than with the other systems, and that it was particularly effective at night, especially when your visual displays are fogging up.
Still got one on my stomach, going in the right direction. And he's giving me another signal to the front, so we're still good.
The soldiers loved it. The feedback was overwhelmingly positive.
And this is a great thing because, as you can see, hands-free.
When we took the concept to the snipers, they really liked the idea of using the belt to not only navigate, but to send covert signals to each other, because very often they need to communicate. They don't want to use a radio. They don't want to use a visual display because that lights up their location.
The Army is also working with several companies in order to develop a haptic glove as a way to relay information during covert operations through common hand signals.
So the soldier wears the glove, does his usual hand signals in the way that he normally does it, and it translates into a tactile pattern.
I think the first community that will have the opportunity to use something like this will be special operations, because it takes a shorter period of time for them to develop and to adopt new technologies. The length of time it takes something to get into the cockpit, whether it's the Army, the Navy, or the Air Force, is a very long period of time. And in part, that's because we have an acquisition system that does not move very quickly.
As for the future,
It would be nice if we could operate in the dust. Our goal would ultimately be, as the Night Stalkers say, the Army's 160th unit, we own the night. They would like to also be able to say, we owned the obscuration or the degraded visual environments. Being able to operate deliberately in those environments would be a very good thing.
Right now, that pilot does all the work in his brain. What we want the aircraft to do is take a lot of that information and integrate it and provide the pilot with options that are relative to whatever mission set he's conducting. So over the next 5 years, we'll actually develop some additional technologies. As an example, cognitive decision aiding systems. So it allows workload reduction on the pilot. So the aircraft is going to start to do more of the work and the pilot's going to be along for the ride.
It seems that time and technology stop for no man. Army aviation officials are already looking at replacing their fleet down the road.
All of our aircraft today were basically designed in the 60s or the 70s, and we've upgraded them with major and minor upgrades over the years, but we've recognized that the capabilities we need in the future, we're just not going to attain those with the current platforms, that we need entirely new platforms of technology. So we're going under a deliberate process called Future Vertical Lift to look at and demonstrate and then develop the technologies needed for the next generation of vertical lift assets.
And while the technology is constantly evolving, one thing is for sure.
You always save lives when you have information. Information before you get to a tactical objective, before you go on a convoy, before you run any kind of operation. If I know what's there, I can be better prepared to meet the objectives.
And while the threat continually changes, Army Aviation is determined to stay one step ahead, pushing the limits of technology to provide greater performance and survivability, ultimately creating a more lethal force for the next generation.